Hello everyone, this is Mr. O'Leary with a video on limiting reagents. So one of the first thing you need to do when solving one of these problems or attacking these problems is you need to find out what is it asking you. So how many grams of ammonia, NH3, can be formed when 2.0 grams of nitrogen react with 10.0 grams of hydrogen according to the equation, NH2 plus 3H2 and 2NH3. So what is it asking? It's asking us how many grams of NH3 will be formed. So grams of NH3. Well, this is really a two-part problem, two different things. We need to go from 20.0 grams of nitrogen, and we also need to go 10 grams of hydrogen. So we're going to start out with 20 grams of nitrogen. So from here, we need to go to what? We can't just simply go directly to grams of nitrogen, NH3, from grams of nitrogen because they're different. You can't have a gram of an apple has different number of them than a gram of a grape. So we go through the mole. Mole speaks the same language. So we go from grams to moles, mole ratio. So mole of N2, the coefficient is 1 N2 to what? 2 NH3. We'll get to that in a second, but then we go from the moles of NH3 to grams of NH3. And remember, the preceding goes in the denominator, and then goes in the numerator. So from here, we can set it up. So we have mole of nitrogen in the numerator. And 1 mole of N2 has how many grams? Where do we look at that? So there are 2 of them. So it's 2 times 14.007 gives us 28.014. Again, preceding goes in the denominator, mole of N2, and then we have mole of NH3. And again, we have 1 coefficient here, so 1 mole of N2 and to 2 moles of NH3. Then we have 1 mole of NH3 in the denominator is how many grams? That's the next thing we need to figure out. So in NH3 there are what? 1 nitrogens. 1 nitrogen and 1 nitrogen times 14.007, the molar mass, gives us a total of 14.007 grams from nitrogen in NH3. Hydrogen, we have 3 hydrogen. Hydrogen has a molar mass of 1.008 times 3, gives us a total of 3.024 grams. And that gives us a total of 17.031 grams for the 1 mole of NH3. Again, we put this in the numerator because 1 mole of NH3 has 17 odd grams. From here, we solve it. The next step in the APSE method, we solve it. And we solve would be 20.0 grams of N2. And we multiply that by our equality, which is 1 mole of N2 over 28.14 grams of N2. Then we multiply that by our molar ratio, which is 2 moles of NH3 to 1 mole of N2. And then we multiply that by our molar mass of NH3, which is 17.031 grams of NH3 over 1 mole of NH3. That is my dog snoring. I'm not sure if you can hear it. So then we just multiply it out from here. This is just basic math. Multiply the numerators, divide by the denominators, and we get a really long number. That's how many grams, but obviously we're not significant to this many decimal places, so we'd have to go up here. How many significant figures do we have here? That would be 3. So 1, 2, 3, draw our line. 1 is less than 5, so we would have 24.3 grams of NH3 produced if 20 grams of nitrogen react. That's our first step. We know that 20 grams of nitrogen will react and produce 24.3 grams of NH3. So our next step, we need to do the same thing, but with 10.0 grams of hydrogen. So again, what is our problem? What are we asking? We analyze this. It's how many grams of NH3 will be produced. Our problem is we have grams of grams of H2. We need to go from grams of H2. We need to go from grams of H2 to moles of moles of H2. From moles of H2, we have to go to moles of NH3. And then from moles of NH3, we go to grams of NH3. Now again, the preceding goes in the denominator. The other goes in the numerator. Quick, easy way to set it up. And so 1 mole of, sorry about the shaking, and 1 mole of H2 has how many grams? Where do we figure that out? To our periodic table, and 1 mole of H2, hydrogen has a molar mass of 1.008, so that's 2 times 1.008 is 2.016 grams of H2. Then mole of H2 goes in the denominator, mole of NH3 goes in the numerator, and if we look here, a hydrogen has a coefficient of 3, so 3 goes in the denominator, coefficient of 2 goes in the numerator for NH3. And then 1 mole of NH3 goes in the denominator. How many grams were in 1 mole of NH3? Sorry, I ran out of room here. We can just scroll up and look. 17.031 grams. Now again, from here, we can simply solve it. So we have 10.0 grams of H2 times 1 mole of H2 over 2.016 grams of H2. And then we have 2 moles of NH3 over 3 moles of H2. Our molar ratio. Then we multiply that by 1 mole of NH3 under in the denominator is 17.031 grams in the numerator of NH3. For me, I just simply go along the numerators, multiply them out, divide by the denominators, and we get our number. Our number is going to be longer. Then we use our significant figures to shorten it. 56.3194444 grams of NH3 is produced. So again, we look at our significant figures. We have 10.0, that's 3 sig figs. Draw our line. 1 is less than 5. So we have 56.3 grams of NH3. Sorry, evaluate, not follow the solution. We're evaluating our answer. NH3 is produced. So when 10 grams of hydrogen are fully reacted, it has the potential to produce 56.3 grams of NH3. And we know that if 20 grams of N2 or nitrogen react, we're only producing 24.3 grams. So when we have each of these react together, they're producing a maximum of 56.3 or 24.3. So nitrogen is our limiting reagent or limiting reactant. It's a reactant, it's on the left side. It's also a reagent. It's just another way of saying it. Now there is a little bit of an easier way of doing this, well, a lot easier way. You could turn both of these 20 grams of nitrogen and 10 grams of hydrogen into moles, do the molar ratio, and see whatever produces the fewest moles. Whatever produces the fewest moles is your limiting reagent. But I just wanted to show you how to do this fully out. Thank you, and have a good day.